Okay, so second part in the building my own handheld series, and in this episode we're going to talk about the audio system. Why I'm starting with the audio system in two reasons. First of all, it's something that I can do in one block that's fairly independent of the rest of the system. It's just going to have a bus feeding into it. The rest is going to be fairly independent. And second of all, I think I can make progress with this fairly quickly, and I don't have all that much time this weekend, so I started working on that. Okay, so first question we have to ask ourselves is what sort of chip to use for that? I mean, we could just use the DAC of the processor or the microcontroller and do everything in there, but I thought it would be really fun to have the original sound chip of some old console on there, and then just use that. And a couple different options here. A great option would be the Yamaha YM2612. This sounds great, although it is fairly involved, and also the datasheet is all in Japanese, and there's people out there who have done a lot of work on that and have got really good results, but I'm not going to go into and build my own system based on that. Also, it is fairly large. If we compare this to the cardboard mock-up of the actual handheld, this is going to cost us a lot of space if we put something like this in there. Although it sounds great, so we're not going to use that. The same goes for this chip, which is the AY38910A. This one also sounds pretty good, but it's huge. And the thing is, something that is fairly similar in functionality is this chip here, the TI SN76489AN. And this is, footprint-wise, fairly small. I mean, could easily fit that in. It's fairly easy to drive. There's a lot of examples out there, so I chose this. And then, as shown on the block diagram, I do not only want to have this, but I also want to have a line coming out from the deck to just do additional supplemental sound effects. So we're going to have to build a mixer of some sort that is going to mix the output from this chip together with the DAC and then amplify everything. We'll do that in the second stage. For the amplifier, I chose this chip here, which I'm holding the wrong way around, I think. The LM386, which is a common small audio amplifier, and we're going to use this. We're not out for massive audio quality or anything here. This is just going to be a fun project. So let's look at a circuit I'm thinking of. And what I want to do is sort of like this. So the audio chip is here, the SN76489, and this needs, the only thing this really needs is a clock input coming from here, and then everything else that's not connected here is just going to be supplied by the microcontroller. So it has an 8-bit data bus and also write enable. The clock, I don't know if I'm going to generate it that way in the actual handheld, because depending on what sort of speed we're running the processor at, we can either divide us the clock frequency for that from the main clock, or we could even have this clock input here just being fed, be fed by the output from the microcontroller on some sort of PWM timer or something. I suppose we could go up to 4 MHz with that, or We could have a 1 megahertz input. This is going, if we do it with an inverter, this is one 74HCT04 and a crystalline resistor. It's not going to take too much space in an SMD package, but it's still going to be noticeable. So if I can avoid having that, I'd like to do that. The other thing is, I have this on a circuit like this because I built a demo board and I needed a clock source because I don't have a processor on this demo board which can actually do any of that. So this is what I chose there. And I might just put this in like this, or I might have another solution for that. For the mixer circuit, we just have our two inputs going through capacitor, going through two resistors, into an op amp. The gain is adjusted here. In the actual console, I'm probably going to use a digital pot here instead of this. Then I don't have to design in a mechanical sort of potentiometer that you can turn, because we're already somewhat limited on space around the circumference here, where we could put something like that. And it's going to be a bit of a hassle having a little thumb wheel coming out through the side. And it would be not much nicer just to use a digital potentiometer, which I'm probably going to do. But for the demo board, I just put a pot on there. This is going into a voltage divider, which allows us to set the signal that comes in here, so the maximum signal range, because the output coming out from here is already relatively strong. And it might be that the lowest setting on this is already too loud. So I just have a voltage divider here to divide it down if I need that. If I don't need it, you could just delete that resistor or not populate it and have a jumper here. That would be fine. Then we're going into the LM386. This is just straight out of the data sheet going into the speaker here from there. Power up here to the chips. And that's about it for this demo circuit to just test out how this chip works. So I first built this up on a breadboard with an Arduino driving it, simply because I haven't figured out how the STM32 works yet, and there is a library available for the Arduino that just makes testing the chips easy. I initially started out doing this not knowing if my Chinese chips were actually any good, so I just needed a quick way to test them, and this was that. From there, I actually built the circuit that you saw on the schematic, and I'm just going to get the clip leads out of the way here. And what this is the sort of audio amplification mixer stage. You can see the two capacitors, resistors going into the op amp here with the gain pot, and then the LM386 here going out to this little speaker. And on this side we have basically the Arduino feeding all the bus and the write enable on this, and then also the inverter up here with the capacitors that were actually missing on the schematic, I'm sorry. But yeah, they're on there. So for the actual handheld circuit, I'm going to use SMD parts for all of these. But this I don't think is available in SMD, so I'll probably have to fit that on somewhere. But it shouldn't be too much of a problem. So I think what I should do is I should hook this back up and we should listen to some examples. So I've got this all hooked up, and what it basically is just it connects power and ground on the two boards, and then also power and ground, and then it also connects the signal from the sound chip to one of the inputs on the mixer. And if I plug this in, it's going to run through a very, very simple program where it's going to play a couple of random notes that I just put in there for different durations. And it's going to loop through that and do that on each of the 3 sound generators. And then it's also going to play some noise from the noise generator. So let me just plug this in here. And so 1, 2, and the last one. And it's just going to play some noise. And then it's going to start again. So this works fairly well. One note is when I plug this in, you hear it being glitchy for a second. Which is because I left the because it takes a second to actually initialize everything, and well, basically until it receives data. That means it's going to play garbage for a second or so. And this is because the not chip enable or not output enable is just permanently on this board. On the actual handheld, I'm going to have this on a pin. So you can actually turn the chip on after we send data to it, which is probably a better way of doing it. But since I only wanted to test these chips, and give me a way, or others a way, to easily play around with this chip. That's why I did it that way. And also, as you can see, I socketed this chip here, so I can plug in my Chinese chips and see how many of them are actually working. So yeah, I think that is the sound system for the handheld, mostly designed. In the next episode, I think we're going to look at the power system, and then we're going to tackle the processor and all the complicated stuff. So yeah, I see you around.